Good morning everyone. Today I am going to take a lecture of probability and statistics, and our chapter number is 2, some spatial probability distribution. We have already seen in our previous lecture what is the binomial distribution and how we solve the different types of question in the binomial distribution. So our second important distribution is Poisson distribution. So the definition of the Poisson distribution is a random variable capital X is said to follow Poisson distribution if the probability of X is given by P capital X is equal to small x is equal to e raised to the power minus m raised to the power x upon factorial x, where x is equal to 0, 1 up to. Okay, so here m is the parameter, so we write this formula p capital X is equal to small x is equal to e raised to the power minus lambda to the power x upon factorial x. Okay, here x is equal to 0, 1 up to so on. So here the lambda is equal to mean. We have already seen in our binomial distribution. In the binomial distribution, mean, that is mu, is equal to NP. Okay, and the variance sigma square is equal to NPQ. Got it? But in Poisson distribution, our mean and variance is equal to lambda. Okay, so this is very important point for binomial and Poisson distribution. In binomial, mean and variance are different, NP and NPQ. But in Poisson distribution, mean and variance are equal. So we write here mean is equal to variance is equal to lambda. Okay, that means here mean is equal to mu and variance is equal to sigma square. Got it? So in this binomial, what is the difference between binomial and Poisson distribution? In the binomial distribution, the number of trials is so small and the probability of success is very large. Very large, that means the number of. Okay, but in Poisson distribution, a number of trials should be infinitely large. That means in the Poisson distribution, the first condition is the number of trials should be infinitely large. Okay, and the probability of success is very small. So in the binomial distribution, we have the two formulas, mu and sigma square, but in Poisson distribution, we always use mean is equal to variance is equal to lambda. Okay, so this is very important formula for Poisson distribution, e raised to the power minus lambda to the power x divided by factorial x, where x is equal to 0, 1 up to so on. So here n is very large, that is number of trials, and success is very small. So if our question given in the form of n is very large, so we use the Poisson distribution, and if a number of trials is small, so we use the binomial distribution. The example of the Poisson distribution, if the mean of the Poisson distribution is 4, then find the probability of lambda minus 2 sigma less than capital X less than lambda plus 2 sigma. So the solution is, first we write the mean of the Poisson distribution. So mean is equal to mu is equal to 4. That means this is the lambda, because of in the Poisson distribution mean and variance is equal to lambda. Okay, so here mean is equal to 4, so variance is equal to sigma square is equal to 4. Okay, But in this question, here we write the lambda minus 2 sigma. So sigma, that means what? Standard deviation. Okay. So here sigma square is equal to 4. That means sigma is equal to 2. Okay. So we find the value of P lambda minus 2 sigma less than capital H less than lambda plus 2 sigma. Okay, so we put the value of the lambda and the standard deviation, that means sigma. So P lambda is equal to 4. So we put here 4 minus 2 into sigma, that means 2 less than capital X less than lambda is equal to 4 plus 2 into 2. Okay, so this value is what? P 0 less than x less than 8. Got it? So here the value of x is between 0 to 8. So first we write the Poisson distribution. So the formula of the Poisson distribution is P x is equal to x is equal to e raised to the power minus lambda lambda to the power x upon factorial x. Okay, where x is equal to 0, 1 up to so on. Got it? So first we put the value of the lambda because of in our question the value of the lambda, that means mean, is equal to 4. Okay. So e raised to the power minus 4, 4 raised to the power x divided by factorial x, and where x is equal to 0, 1 up to so on. Got it? Next step is what? Our next step is we find the value of the x, that means probability of x between 0 to 8. So we write here the probability of 0 less than x less than 8 is equal to what? So here we write summation I x is equal to 1 to 7. Why we write here 1 to 7? Because of here we find the probability of 0 less than x less than 8. That means 0 and 8 is not included in this term. Okay, so we write 0 less than x less than 8. That means summation x is equal to 1 to 7. Why we write here the variable x? Because of here the power of 4 and in the factorial we write here only the variable of small x. So in the summation we write here only the variable small x. Got it? So here we write the summation x is equal to 1 to 7 e raised to the power minus 4 and 4 raised to the power x divided by factorial x, x is equal to 0, 1 up to so on. Okay, after writing this state, we put one by one the value of x is equal to 1 plus x is equal to 2 plus x is equal to 3 plus x is equal to 4 up to x is equal to 7, and we get our final answer is 0.9306. Okay, if we put the value of, first we put x is equal to 1. So this sum is e raised to the power minus 4, 4 raised to the power 1 divided by factorial 1 plus we put x is equal to 2. So our next term is e raised to the power minus 4, 4 raised to the power 2 divided by factorial 2 up to our last term is what? Our last term is e raised to the power minus 4, 4 raised to the power 7 divided by factorial 7. After solving this step, we get the final answer 0.9306. That means with the help of Poisson distribution, in this question the mean is already given in our question and our given find the value is given in the lambda and sigma form. That means the mean and standard deviation. So first we write the mean. After that we write the variance. Mean and variance are equal because of we solve the Poisson distribution. Okay, so this is our final answer 0.9306. Okay, this is the second example of the Poisson distribution. If the mean of the Poisson variable is 1.8, then find number 1 p x greater than 1 and second p x is equal to 5. So first we write the formula of the Poisson distribution. So the formula of the Poisson distribution is P capital X is equal to small x is equal to e raised to the power minus lambda, lambda to the power x upon factorial x. Okay, here x is equal to 0, 1 up to so on. Okay, so in our question, we are given in the value of the mean. Mean that means mu is equal to lambda is equal to 1.8. So first we put the value of the lambda. So here P capital X is equal to small x is equal to put the value of the lambda e raised to the power minus 1.8 1.8 raised to the power x divided by factorial x. Okay, here the value of x is 0, 1 up to so on. Got it? After that, we write the formula of the Poisson distribution. We find the value of p x greater than 1. Okay, so first we find the value of p x greater than 1 is equal to, so what is the limit of the value of the x? Because of x greater than 1, that is 2, 3, 4, 5, 6 up to so on. Okay, and our last number is what? Last number is the thing, because of here only the value of x greater than 1. Okay, so here we write the x greater than 1 is equal to, you have already known that the total probability is 1. Got it? We have already seen in the basic probability chapter, in our first chapter. So here we write 1 minus p x less than equal to 1. Okay, we write here x less than equal to 1. That means what? The total probability is 1. So here x greater than 1 is equal to 1 minus p x less than equal to 1. Okay, so p x less than equal to 1. That means we write here 1 minus p x equal to 0. Okay, and plus p x is equal to 1. Okay, so put all these values in according to our Poisson distribution formula. So we put the formula of p x is equal to 0. That means e raised to the power minus 1.8, 1.8 raised to the power 0 upon factorial 0. What is the value of the factorial 0? Factorial 0 is equal to 1. Okay, plus we put the value of x is equal to 1 in the Poisson distribution formula. So e raised to the power minus 1.8, 1.8 raised to the power 1, because of here the small x is equal to 1 and divided by factorial. Okay, so solve these values and we get our final answer is 0.5372. Okay, so we write here 0.5372 for the value of p x greater than 1. Okay, our second is p x is equal to 5. Okay, so p x is equal to 5. That means what? We put here p x is equal to 5 is equal to e raised to the power minus 1.8, 1.8 raised to the power 5, because of here we write the x is equal to 5 according to our second question. Okay, so e raised to the power minus 1.8, 1.8 raised to the power 5 divided by factorial 5. So this is the second example of the Poisson distribution. I will continue this topic in our next lecture. Thank you for watching this video.